Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be exploring more about equilibrium of forces, a continuation from our previous lesson. But before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we understood what forces are. We defined equilibrium of forces, using examples and applications. We also went ahead to explore resultant and equilibrant forces, and it was very exciting. Before we begin today's lesson, let's take a quick look at our lesson objectives. By the end of today's lesson, you will be able to define moments of force, know its formula and examples, understand principle of moments and applications of force, torque. Sit tight, let's begin. A moment of force, also called torque, is the turning effect of a force acting on an object around a pivot or axis. It measures how effectively a force causes rotation. Here, pivot is the fixed point about which an object rotates. It is measured in Newton meter. Example: opening a door and using a wrench to tighten a bolt. The formula for finding the moment of a force. Moments, torque, equals F times D, where F is the applied force in newtons, and D is the perpendicular distance from the pivot to the line of action of the force in meters, m. Let's see more about moments. There are two major types of moments. 1. Clockwise moment. This is when the force causes a rotation in the clockwise direction. 2. Anticlockwise moment. This is when the force causes a rotation in the anticlockwise direction. Now, the principle of moments. For an object to be in rotational equilibrium, the sum of clockwise moments equals sum of anticlockwise moments. This principle helps us understand balance in systems like seesaws or weighing scales. Let's explore the applications of moments. Torque plays a vital role in daily activities and engineering. In daily life, opening doors and turning a steering wheel. For engineering, cranes lifting heavy loads and bridges use moments for stability and functionality. And so much more. You can go ahead to explore more applications of moments in daily life. Now let's solve a problem. A force of 15 newtons is applied at a perpendicular distance of 3 meters from a pivot. Calculate the moment of force and determine its direction if the force causes a clockwise rotation. Solution: moment, torque, equals F multiplied by D. Torque equals 15 newtons multiplied by 3 meters, which equals 45 newton meters. The moment of force is 45 newton meters, and it acts in the clockwise direction. Since the force causes clockwise rotation, the torque direction is also clockwise. You are doing well. I'm sure you understand it. Now it's your turn. Here are two quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's recap. Moments, also known as torque, measure the turning effect of a force. Formula for finding torque equals F multiplied by D. Moments can be clockwise or anti-clockwise. Moments have application in daily life, engineering, and even sports. In our next lesson, we will be learning about parallel forces and more about equilibrium of forces. Well done! You've come to the end of this lesson. Keep practicing what you've learnt. I will see you in the next lesson.